Let's jump right into this explainer. We're going to dive headfirst into the architecture of prediction. We'll be looking at exactly how different AI models, massive supercomputers, and statistical masterminds are trying to forecast the 2026 World Cup. And, spoiler alert, we'll see why their blind spots might completely change how you view artificial intelligence. So let's see if machines can actually crack the code of the beautiful game.
Can AI predict the unpredictable? I mean, it's the ultimate question, right? For fans, for data scientists, or just anyone filling out an office pool bracket as we head into the biggest sporting event on the planet. We have to ask ourselves, can cold, hard code truly account for a sport where a single unpredictable bounce of a ball literally changes history?
Just to wrap our heads around the scale of the math involved here, remember, this expanded tournament features a massive 48 teams and 104 matches. With that brand new round of 32 added in, simulating this entirely unprecedented format is, well, it's exponentially harder than ever. The bracket is an absolute labyrinth. The sheer volume of permutations is staggering, and it's pushing these prediction models to their absolute limits.
Section 1. AI's top World Cup picks. Let's start right off the bat with the heavy hitters and see who the machines are actually picking to lift the trophy.
Because when you feed in the raw historical data, a very clear hierarchy emerges. The Opta supercomputer crunched the numbers from tens of thousands of simulations and delivered this definitive ranking. It puts the 2018 winners France, sitting comfortably at the top with nearly a 30% probability, leaning heavily on their incredible squad depth and Kylian Mbappe's attacking prowess. Defending champions Argentina and Lionel Messi follow up at 14.4%, with Spain trailing just behind. The machines absolutely love a proven track record.
But what happens when we move away from traditional supercomputers and ask the conversational AI we use every single day? It turns out, when you ask different artificial intelligence platforms the exact same question, you get wildly different answers based on how they were built. You see, AI isn't just one monolithic brain. It has distinct personalities, and those personalities shape the data it feeds back to us.
Section 2. How chatbots think differently. Let's peel back the curtain and look at the distinct psychological profiles of our three major conversational AI models.
When researchers tested them side by side, they found some really fascinating differences. GPT is built to be useful above all else, so it actually manufactures precision. It will confidently give you a fully ranked list of winners. Claude, though? It acts more like a cautious academic, designed to prioritize honesty, so it constantly flags what it doesn't know. And then there's Gemini, operating like a hyper-caffeinated scout, optimized for speed and pulling live indexing data right from the web.
This contrast brilliantly illustrates their underlying philosophies. GPT relies heavily on what we call generated confidence. Think of it as that friend who will confidently commit to exact numbers and percentages just to give you a definitive answer, even if they're kind of just guessing. Claude, on the other hand, operates with epistemic humility. It's the cautious academic who hates manufacturing false precision. It will flat out refuse to guess a specific scoreline for a match that hasn't happened yet, simply because it lacks verifiable facts.
These underlying personalities dictate their blind spots, which has huge implications for how we use them. For example, Gemini's live data indexing meant it caught Lionel Messi scoring his 6th goal in real time. GPT, relying on older training data, missed it completely. But the most fascinating failure was definitely Claude. Its extreme caution actually caused it to reject true tournament upsets. When fed the real-world fact that the tiny nation of Cape Verde advanced over heavyweights, Claude flat out called the information fabricated. The facts were literally too surprising for its cautious programming to believe. No way, right?
Section 3. The heavyweight statistical models. Now let's move away from conversational AI and look at the hardcore academic math powering the professional predictions. A fascinating research paper applied a method called sufficient dimension reduction, or SDR, to a heavy statistical model. But simply, instead of just looking at a team's current ranking, or ELO rating, SDR analyzes the recent trajectory of that rating over time. It proves that whether a team's rating is trending up or down is vastly more predictive than just knowing where their rating sits today. It captures the momentum of a squad, which, as we know, is absolutely crucial for a month-long tournament.
Meanwhile, take a look at the inputs for this massive algorithm built by European statisticians. They used a machine learning random forest algorithm crunching 8 solid years of international match data. They factored in combined bookmaker odds and even tweaked the data based on individual player market values. And the crazy part? After running 100,000 simulations using all this data, it actually crowned Spain, not France or Argentina, as the most probable victor.
Section 4. The human wild cards. So how does all this raw computing power stack up against human intuition and unconventional logic?
Well, let's look at what the flesh and blood experts are saying. ESPN pundit Steve Nicol trusts his eyes and deep football knowledge, backing the AI favorite, France. But then you have mathematician Joachim Clement, who steps entirely outside the box with a completely different approach to the numbers.
The absolutely crucial point about Clement is his track record. The guy correctly predicted the 2014, 2018, and 2022 winners. But he doesn't just look at expected goals on a pitch. He uses non-traditional macroeconomic metrics, a country's GDP per capita, their football infrastructure, population size, and underlying football culture, all while baking in an element of pure chance. Using this wild formula, he predicts the Netherlands will shock everyone and win the whole shebang.
Section 5. Why logic fails in football. This brings us to the fundamental limitation of every single model we've looked at today.
0%. That is the exact probability the Opta supercomputer gave the island nation of Cape Verde to advance before their tournament started. We are talking about a country of just over 500,000 people, fielding a 40-year-old goalkeeper from the Portuguese second division. AI gave them a literal 0% chance. Yet, they qualified from their group anyway and drew against powerhouse Spain. It highlights a massive, glaring blind spot.
The really crucial takeaway here is that AI is blinded by its own training. They hit what researchers call the pattern matching wall. For example, all three conversational models we looked at earlier predicted Mbappe would win the Golden Boot over Messi, even when fed live data showing Messi had more goals in the moment. The historical pattern linking Mbappe to knockout stage success was just too deeply embedded in their neural networks to override. They simply couldn't adjust to the reality unfolding on the pitch. It's the inherent danger of relying entirely on algorithms, not just in sports, but in any field where human unpredictability plays a role.
Our source brilliantly summarizes the problem. You can have millions of data points and perfect, elegant code, but these models are fundamentally doing pattern matching, dressed up as absolute certainty. Football, however, is ultimately dictated by unpredictable human chaos. One bad referee decision, one weird bounce off a crossbar, and the entire mathematical architecture collapses like a house of cards.
So, if machines are just confident mirrors of our past, can they ever truly predict the beautiful game's future? It's definitely something to think about the next time you see a supercomputer claiming to know exactly how a tournament, or really anything else in our lives, will end. Are machines just offering a high-tech reflection of our past, or can they actually calculate the magic of tomorrow? Thanks for joining me on this explainer. I hope it helps you see the numbers behind the beautiful game and the AI models we use every day in a whole new light. See you next time.